One second. Hey guys, how are you all?
Good. How are
Okay,
you?
do you have any questions on the session one test? I did send it out to you, all of you.
I had one question. So I think it was like number, I forgot the number, but one of the questions, there were no answer choices. Like for the multiple choice one, it said FGH or whatever, but on the picture, there were no like answers.
I'm with you, ma. I saw that. I corrected it. I removed points on the test.
Okay.
But good find. I really like it. Wait, let me go to the test. I really wanted to show some of you. My main concern is why some of you didn't take the test. I'm forced to ask you. I don't have any other go but to ask. So was it a homework? Let me see. Uh, 1 second. Where is this? Geometry. Oh, yeah. Shrikar, that was good work. Akash, that was good work. Navneet, it was good work. Manya was good work. Okay, let's see. Uh, did you take the test during the class, guys? Oh, no. Sorry for that. Sorry for that. No. Wait. Oh, I had assigned it as homework, right? Shreya, did you take the test?
Well, I tried to take the test on Saturday, and every time I tried to submit it, it kept deleting my answers. So then I tried again today, and it was working. But then when I tried to submit it, it said the deadline had passed, so I couldn't actually submit it.
Yeah, it was due on 31st, right? Okay. Uh, okay. Prisha, you took the test, huh?
Sorry, Auntie, can you repeat that?
Did you take the test?
I didn't submit the test. I started it, but I didn't submit it.
Okay. Samantha, did you go over your test? I had individual feedbacks for each of you. Oh my gosh. Okay. Akash, did you look over the test, Akash? I was really happy with your test. Shrikar as well. Both of you not taking at school, right? Geometry?
No.
Yeah, but you did a great job. Very nice. Navneet as well.
I didn't get any feedback.
You didn't get any feedback?
No.
Did you check your email?
Oh, email? Oh, I thought it was on Google Classroom. Yeah, I got it.
No, I released it late only, Akash. Did you have any questions on that?
I took it over like a bit of time because some of the things I didn't know. So I just learned it and then did it.
Okay. See, slowly many of them are done. Did you have fun? 1 second, guys. Huh? 1 second, guys. Okay, let's go ahead, guys. Okay, I would like to know what are you doing in school for Manav and Manya? What are you doing?
Well, we just finished triangle congruence. I think we're doing similarity now.
Okay. How about you?
We're doing triangle congruence, and we have a test over like everything. Like we were doing triangle proofs and everything, and we have a test on it this week.
I see. I see. Manya, you've sent me your full
Yes.
calendar.
Yeah, I sent you the syllabus.
Yeah. I have it. Hold on. I want to go over it once, but other than that, who else I wanted to ask? Let me ask, please. Priya. Prisha, what are you doing in school?
Right now we just took like the mid unit 2 test and we're doing like angle chasing, like we just finished that and we're gonna like start a new unit like next class. So
It's easy for you?
yeah, I get it.
Okay. Okay. I can go over the rest. But Manya, you know what? Did you observe? This is a part of your second grading period, right? Congruence.
Wait, what?
Congruence is a not. Oh, you're in your second grading period, huh?
Yeah.
Oh, wow. Okay. Okay. Interesting. So, okay. Let me go over let me finish. My plan is to finish the rest of congruence and then get into special triangles and quadrilaterals. So, let me look at it. So last week we did complete congruence third and fourth part, right? Prisha, sorry, Prisha, you have to remind me once more. I was not listening to you. I'm sorry. What was that?
We just took our unit mid unit 2 test and it was just like angle chasing and like a lot of definitions like same side interior and exterior and stuff. So
Oh, that should be easy for you right now, right?
I got that.
Okay. So let me go ahead and see this one. I will review all of what we learned. We also learned HL congruence, right, guys? We learned HL congruence. Let me see this one. Okay. Can you say whether these two triangles are congruent? If they are not, it's fine. If they are, I want what type of congruence? Hmm. Manav, that's correct. Prisha, incorrect. Shrikar, that's incorrect. Manya, that's correct. I didn't get other answers. I would like to discuss with each of you guys.
Auntie, I sent in new answers. That one correct?
Same, I also sent an answer.
Dear. Let me go over it, guys. I'm confused. Sure, Shreya. Prisha, that's not correct. Akash, that's right. Navni, that's right. Okay. Okay, guys. In general, right? See here, guys. See, it's very deceptive. This, from the figure, you know what you infer. This angle is equal to this angle. This angle clearly two line. They are congruent. Having said that, you see this angle, side congruence. Angle, side congruence. Do you see it? So it is AAS. Just follow clockwise or anti-clockwise when you look at it, right? It is AAS congruence. Any questions? Aditi, are you following? I didn't get an answer. I feel.
Wait, Miss Priya.
I said my answer. Miss Priya, I said my answer already.
Sorry, ma. Okay. Wait, honestly, I didn't see yours.
Wait, Miss Priya.
Yeah, ma.
If you start from the angle that's touching the other triangle, and if you went anti-clockwise, wouldn't that make ASA?
Come again. Which one? If you start, let me name it, Shrikar.
If we start on C and go anti-clockwise, wouldn't that make it like C on this on the second triangle? Wouldn't that be oh wait, never mind.
No. The problem about this is I understand your confusion. See, A, B, C, A,
No, I got it. I see what I did wrong. I went anti-clockwise.
EDC. You get it, huh?
I got what I did wrong.
Miss
Yeah.
Priya, I
Go ahead.
thought it would be ASA, but can you explain AAS one more time, please?
Why did you think it is ASA, ma? You explain. I will let you know what is incorrect about it.
Okay, well, first of all, like the picture that I drew in my notes, it kind of looked like that too. And also because the included side for like both of them, like it has one line. So like it's saying that both of them are congruent. So
Yeah, but 1 minute, ma, 1 minute. That side, right, is not the included side, right? If this is the included side, then these two angles should have been given. You see what I mean?
yeah, I understand that.
So those two angles were not given. That being the case, see, the problem is ABC, this clockwise direction is congruent to EDC. It's not CDE. Do you get it?
Yes.
So from here, when you see B equal to D is given, congruency. And then C is given. Do you see? So
Yeah.
basically AA and the side is AB and DE. Do you see?
Mm-hmm.
Basically, you have a side and then AA. It's AAS. Do you see?
Yeah.
Shreya, did you get it?
Yeah, I'm writing down the notes, so I should like it.
You also Okay, so let's see. How about this? Yeah, I will review a few of this, I feel, because I'm not very comfortable. Let's see. What congruence? Is it following congruence? What type of congruence is this? We need to write out proofs. Manya,
Yeah.
it's a right angle, a right triangle, right, Manya?
Oh, wait, hold on. Is my answer correct?
Yes. Aditi correct. Akash correct. Prisha correct.
Wait, Auntie, is my answer correct?
Prisha correct, I said. Yeah.
Oh, okay.
Navneet correct. It's okay to go wrong, but try. Shreya, the problem is you lost the train last week, last or the previous week. Now we are not able to follow, I feel. Shreya, this is a right triangle, right, Shreya? Good job, Trinita. Correct, ma, but what congruence, Mamanya? Samantha? See, the only types of congruence you have are SSS, SAS, AAS, ASA, and then you have HL for right triangles. These are for any type of triangle. Samantha, what is your answer? Your answer is not.
Yeah, I
Telling
forgot what the I forgot that there was like I forgot if it was like HL or if it was something else like that it
So
stood
here,
for.
what do you think it is?
I think it's HL. So
It's
I
HL.
forgot like which letters it was though. So then I searched it up really quick and then it said RHS and I was like, oh. So
So if it is right triangles, right? The hypotenuse is already congruent and this side is common. So definitely congruent. It's the same side, right? So one leg of each of the triangle and the hypotenuse are congruent. This is the leg, this is the hypotenuse. So HL congruence. If it is a right triangle, that is accepted.
oh, what the-
Aditi, Akash, Navneet, correct. Prisha, can you explain Manav, correct? Srinita, correct.
You want me to explain my answer?
Yes, ma, definitely.
Okay.
Samantha, correct.
For this one, oh wait 1 second. For this one, I thought it might be SAS because the rule for that one is like if two sides of like the included angle of one triangle are congruent to the second, then both the triangles are congruent.
But where the angles are not equal, right? Nothing is given, right?
Yeah, but doesn't it give us that two sides are congruent?
Yeah, that's correct. So side, side, and then what? This is a common side, right? Then definitely it's congruent, right?
Mm-hmm.
So what congruence is that?
Sides.
Make sense?
Kind of.
Why kind of? Tell me. Where is it not making sense?
So are you saying like the line in the middle like is that congruent for both of them? Like
What I'm saying is, you split up this triangle, it comes this way, right?
yeah.
We already know these are equal, right?
Mm-hmm.
Since the common side, it's the same side actually. So can I say that they are congruent?
Yeah. So it would be SSS.
Hmm.
Okay, thank you.
How about this? You have to tell, for each, you have to tell whether it's congruent. If it is congruent, what congruence? Mm, Oh my gosh. Navneet, I really like your answer, but that's incorrect. You know why? Good thought though. I'm glad you came up with it. Shreya, can you explain your answer?
So I thought it was like that because, oh, wait, never mind. I think I get it.
No, tell me, ma. Meaning it's okay to go wrong, but I can help. I'm saying, right?
So I thought it was like angle, side,
Okay. Angle. That's all is given.
but then I like the things in the middle.
Both are equal. These both are equal because vertically opposite angles are equal and the third angle of a triangle will be equal to the third angle if the other two angles are equal. So all the angles are equal. That doesn't say anything about congruence. There is no AAA or SSA congruence. Please don't get confused. There is nothing like just because the angles are equal. Angles will always be equal even if they are made bigger because angles cannot change. So here they are not at all congruent. So angles being equal, all the three, doesn't say anything about congruence. Navneet, did I clarify your question?
Yeah.
So Manav, can you explain your answer? Why did you say AAS?
Because for the can I annotate?
Mm.
Is it because like these two and these two are parallel? Because this angle and this angle are congruent, and then this is the transversal.
Yeah, but who said that this is congruent to this? I can draw parallel lines. I can draw lines like this. Are they equal? Do you think they're equal?
No.
So
Yep.
just
Yeah,
Mhm.
but they have like the same angles and stuff.
That's what I'm saying, right? Meaning angles, I can have them the same. Okay.
Oh, never mind then.
You see
Then
what I
I,
mean?
yeah,
Angles
then I
cannot be-
don't know. Then is it not congruent?
Yeah, they are not at all congruent. Just because they've given two angles as congruent, I can't conclude anything from here. So no congruence. Prisha, did you get it?
Yes.
Aditi, did you get ma?
Yeah, I put my answer in the chat already.
Yeah, I saw.
Wait, but Auntie, if you think about it, like if they give us that two angles are like congruent, like the angles that they give in the middle, like if they're vertical angles, then shouldn't they be congruent?
Okay, let's consider this one. They give you two angles. Okay, let's say they give you two angles. You're saying, in this case, they give you this is equal to this. Okay. And they also give you this is congruent to this. Are the triangles congruent? Yes, they are, because angle, side. This is a common side. By AAS congruence, they are congruent. Here they are not. There are only AA. Nothing else is given. I can't say anything. Do you get it?
Yeah.
Prisha, did I answer your question?
Yes.
Okay. Let me go ahead and I'm not comfortable at all. I don't know why, but that's what it is. How about this? Is there any congruence here?
Can you check my answer, Miss Priya?
That's right. Samantha, correct. Manya, correct. Manav, correct. Akash, correct. Adit, uh, Aditi, is that right?
Oh, wait, I realized my mistake. Oops.
Akash, Manav, Samantha, Manya, correct. Navneet, correct. Srinita, what's going on? Keeping quiet? That's not you.
I'm kind of confused about this one.
Then say confused, right? Then only I'll know. Why?
I don't know. I'm not sure.
This is the common side. There are two angles given. Can I go like this and see? Shrikar, what is going on? This is AAS. Similarly, when I go this side, right? AAS. Do you see for both the triangle AAS? Make sense?
Yeah.
Okay, there is congruence. Okay. I really want to keep going. Okay, let's see. Okay. How about this? How about this? Want to work on a couple of proofs as well, guys. I want you to fill in both the values. What is congruent to what and by what?
Is my answer correct?
Yes, Manya, that is. I'm going crazy with answers. Different answers are there. Manya, the triangle is correct, but your reasoning is incorrect.
Yes, Priya, is my answer correct?
Oh, Aditi, correct. Good job, Aditi. Mama, I'm checking one by one, ma. Manya, Manya, the reasoning is incorrect. Okay, the reasoning is incorrect, Navneet. Srinita, the reasoning is incorrect, but the triangle values are correct. Akash, correct, Akash. Yeah, both are correct, Akash. Manav, the reasoning is incorrect. Prisha, you've given me the reasoning that's correct. Shreya, reasoning is correct, but I don't know what triangle is congruent to what. Both needs to be given, right? Can you send? Okay, I'm going to go over it. Okay. So here, IK is the angle bisector of JIL. Okay, that means what? This is congruent to this. This is a common side, right? And then IK is perpendicular to JL. Now, how am I going to write? First, let me cover the hypotenuse and then the common leg. So they have given IJK, right? So I have to go by this way, IJK. So hypotenuse, the base leg. So that will be ILK. IJK is congruent to ILK. Okay, now what type of congruence is this? There is no need to talk about HL congruence because hypotenuse, they have not given that it's congruent. It is a right triangle, I agree. But then,
Wait, but if it's an angle bisector, the angle it bisects, the sides are congruent.
agree. So,
So wouldn't it be HL?
You bring up a good point. Hold on. It cannot be HL because they have not given that this is congruent, right?
Wait, but could you assume they're congruent because like they gave the angle bisector?
They gave the angle bisector. That means what, Manav? This is equal to this. Only the legs are congruent. Nothing is mentioned about the hypotenuse congruence, right?
Yeah.
Since you bring up this point, I want to note this down. Hold on. There is something that
I have a
did not
question.
hear. Yeah, go ahead.
So if you take one side as A and the other side like as B, wouldn't the hypotenuse be the same for both the triangles? Because the legs have the same value, so A squared plus B squared both equals the same. So it could be
Yeah.
HL and side.
I agree. I agree. But directly from what is given, see that one you're deriving, right? Your hypotenuse you're deriving because it's a common side. So with that you're saying, right, Akash? I agree. Your 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 what to say? Your argument is valid. But what is given here? This is congruent to this. This angle is congruent. This angle is congruent. Easily derivable is AAS, right?
Yeah.
Am I making sense,
Then
Akash?
would it be angle side angle?
That is what I wanted to bring up. Angle, see, from what they have given, it is AAS. You all agree with me, right?
It can be both.
It can be both, yes. You can derive that this is a common side, so you can as well say it is ASA. But again, you're deriving it. You see, this is a common side you're saying. But from whatever data is given, if you consider this, it's only ASA. Do you see? Whatever is given, just use that. If you're not able to use that and derive a result, and I'm sorry, if you're not able to use what is given, come to a result, then you use something derived. Am I making sense? Guys, am I making sense?
Yeah.
Okay, how about this? See, it can be both. ASA, AAS, they have to accept both very honestly. Okay. How about this? How about this? I think we need to move on though. A lot of, yeah. Please, both the answers, send it to me. Okay, they are congruent, guys. Srinita, it is congruent. Okay, I'm seeing a little bit of a. Okay. See, the more problems you do, it's easy. Okay. Prisha, Akash, Manav, correct. Shrikar, correct. Manya, that's, oh, sorry. No, Manya, Shrikar, you have to send it to me. Manav, correct. Akash, correct. Prisha, correct. Srinita, that's not correct. They are congruent. When you look at them, right? Aditi, there is no SAA, it is AAS only.
Oh, I didn't know what it was called, so I just did AS.
That's why I'm always saying, remember SSS, SAS, AAS, ASA, HL, that's all. There is, huh?
Like I said SAA or AAS, so
Yeah, I saw one of the answers is correct. I agree. So here K and W are congruent. E is the midpoint, means these two are equal. KEG, this is congruent as well. So basically it is ASA. ASA. Am I clear? Shreya, am I clear? Samantha?
I thought definition of midpoint made K and G and H and W equal. My bad.
KE and WH. KE and EW are equal.
I know it's wrong.
It's not- No, as long as you understand, it's great, ma. No problem at all. Okay. Now I want to do some proofs with congruence. Let me see. Okay. How about this? We are going to write a proof for this one. Full with statement and reasons we'll write. Come on. You guys are going to help me. Okay. Now, guys, if you want to prove two triangles are congruent, right? If you want to prove two triangles are congruent, if it is to prove two triangles are congruent, your last line should be SSS, SAS, AAS, ASA, or HL. So your last line reasoning should be this congruence, that congruence. Okay. If you want, if they say triangles are congruent, if they say this and ask you to prove AB is congruent to BC or angle C is congruent to angle D, something of this sort, if they ask you to prove, right, then the last line reasoning should be CPCTC. What is this? They are congruent, right? So the congruent parts of corresponding parts of congruent triangles are congruent. This should be your last statement. If they give you that the triangles are congruent, you have to prove one of the sides or one of the angles are congruent, then you need to use the last reasoning as corresponding parts of congruent triangles are congruent. Suppose you have to prove that the two triangles are congruent, it has to be one of these congruents as the last statement. Got it? Let's try this one. Now see what they have asked. U is the midpoint. I'm going to do this for you. U is the midpoint. You have to prove angle 1. See, one of the parts is congruent is what you need to prove. They have given that U is the midpoint and MUT is congruent to SUT. So U is the midpoint means these two are equal. And they've already given, see, this belongs to this. They've given that the triangles are congruent. So you know what I'll do? I will say U midpoint of MS given. Then what will I do? MU is congruent to US. Definition of midpoint. Then I'll say, I have to prove that the triangles are congruent. So it will belong to which? See, to prove is that the triangles are congruent. So what do I do? Which one does it belong to? It belongs to this one. So I have to prove it via one of the congruents. So what do I do now?
One is congruent to two.
One is congruent to angle 2.
Angle bisectors theorem or given. Yeah, sure.
1 minute, ma. What is that? Angle 1 is then what? Then what will I do?
How do you write UT is congruent to UT?
Yeah, UT is congruent to T. What is that? What is it called? What property is that?
Reflexive?
Good job. Reflexive property.
What does that mean?
My UT.
Wait,
See,
what's reflexive property?
remember we studied reflexive property, what was that? We learned about substitution, we learned about commutative, associative. We learnt about so many properties, right? Addition property of equality, subtraction property of equality, division property of equality, multiplication property of equality. Then we learnt about reflexive property. Reflexive property was where we said a line is equal to the same line, meaning other way when you go, ut is congruent to u means it's reflexive. Even if you reflect the line, right, it's just the same. So that's reflexive property of equality. And then remember, Akash, we also did substitution versus what was the other one?
Transitive.
Transitive. Good. A substitution versus transitive. This is reflexive. Am I making sense?
Yeah.
You say A equal to B, B equal to C, then you say A equal to C. This is transitive. It also applies to a line. Similarly, if you say A equal to B, A equal to D, then B equal to D. That is substitution. Now, if you say on a line segment, right, AB equal to BA, that is reflexive property of equality. You got it? Now, let's go back again. So this one would be reflexive property. Now what? Now what is the next one? What's the next one?
Triangle MUT is congruent to triangle SUT because
By
of
what property? By what property?
angle side, so AAS.
So
Isn't
basically,
that
this
SAS?
side angle side, right,
Oh,
ma?
okay. Again, side angle side, yeah.
SA is congruent. So
No, I
this
thought that was an angle for a sec, my bad.
no problem, ma. As long as you understand, it's fine. Are you all with me? Okay. How about this? I want to do a different one. I don't want to prove triangle congruence. Instead, I want to prove parts are congruent. This one is good. Let's see this one. Try that one.
How do we write our proof?
Let's see. You want me to do?
No, like how do we like show like how do we like write our proof? Where do we write our proof?
Okay. The way I want you to do it was, I want you to reason it out. You want to try Manav?
What?
You want to try it on the board?
Yes, sure.
Go ahead. First what? Only when you vocally voice it out, then you will really understand geometry. Go ahead.
Is it AE equal D?
Okay. So AE equal lemma congruent.
Congruent to D.
See, and then the lines are also important in geometry. It means line segment.
Then AB is congruent to DC. And then
Let me mark it, otherwise I can't follow. AB is congruent to DC. Okay.
And then EB equals EC, congruent to EC.
Where is it given? That's not given, right?
No.
See, even I'm not sure how to do this. Let's say.
Oh, do you do BC equals BC? Or BC equals CB?
Yeah, but that is not even in the triangle, right?
Yeah, I'm a bit confused. I don't know how to do this.
I think first you have to prove that AEB is equal to CED, and then C.
Completely makes sense, but how will you prove it, Akash?
First you prove the two triangles are correct. Then you prove that the angle ABE is equal to ECD. And then 1 and 2 are congruent because
Good one. Yes, that seems right. But yeah, I really like the idea. That is correct, actually.
Auntie.
Uh-huh.
Okay, I don't know if this is gonna work, but if we know that 1 and 2, wait, actually, never mind. That would not work.
No, you
Oh
can
yeah,
see.
you could say. Oh yeah. Never
1
mind.
minute, Akash. 1 minute, Mana. Akash, you were saying something, right? Yeah, but then how will you prove those two triangles are congruent, Amma? Akash, the route seems perfectly correct. You're saying we will prove that AB is congruent to ECD. So that way the two triangles are congruent. And I can say that these two angles are congruent. So this angle 1 and 2 will be congruent because they make a supplementary pair, right?
yeah, but there's not enough proof that
Perfectly right. But let's see. No. We are missing something.
Could you, if you use ABE equals DCE, could you use side angle side?
But where is the angle?
Angle B and angle C.
1 minute, wait. Am I missing something? Wait, 1 minute, guys. Did I
I
miss?
think you can use side angle side to prove they're congruent.
Side angle side. But where is the angle?
The angle ABE and DCE.
Who said they're equal?
Because angle 1 and angle 2 are congruent.
you're proving.
That is to prove, right?
Yeah, but you also know it. They also give it to you, but you just have to prove it.
Manav, 1 is congruent to 2 is what you need to prove, right?
Yeah.
Then how can you use it as given?
No, I'm not. No, I'm not using it as a given. I'm just saying we can say ABE is congruent to like DCE because like they make us.
How will you prove that? I'm asking. How will you prove that triangles are congruent?
I don't know.
No, I'm stuck here. Honestly, I'm stuck. So ABE is congruent to DCE. That's correct. That's how we need to prove. But how are we going to say? I feel like there's some data.
Wait, could we say that angle AEB is congruent to DEC?
Why? Meaning, do you have a reason on it?
Is it like I don't know what it's called, but it's like this isosceles triangle theorem or something?
I am with you, Manav. Actually, A is equal to D, we can prove, but they have not given that as isosceles triangle, right? Let me check with
But the two sides are congruent, so it's like.
Oh, yeah, you're right. Good job, Manav. Correct. Very nice. That's right, Manav. Yeah. See the oh, nice, Manav. Very nice. So here, A. I'm sorry. This side is congruent to this side. That is the basic clue, guys. So in any isosceles triangle, right? The two sides are equal. The angles opposite to equal sides are equal. That's the definition. That is called the isosceles triangle theorem, though. But then we would have learned it in 5th or 6th grade. In an isosceles triangle, the angles opposite to equal sides are equal. So, as a third point, you can
you could use angle A and D. Yeah.
angle
Like
A and D.
D.
Yeah, that's what. EAB angle is congruent to EDC. Why? Because isosceles triangle theorem. That comes out as theorem in geometry. But in your 5th, 6th grade, you would have learned that in an isosceles triangle, the angle opposite to equal sides are equal. So that way, these two are congruent. When those two are congruent, I can conclude EAB triangle is congruent to EDC. What congruence is that, guys?
Side
Please. Huh?
side angle side.
SAS congruence. So when you have that in place,
And then
Okay.
and then for the last one, you can just say you can go to angle 1 equals angle 2.
I can't write.
Or you have to say B equals C because
Exactly.
CPPTC.
EBA, I will have to say that angle is congruent to ECD. Why?
CPCTC.
CPCTC. Corresponding parts of congruent triangles are congruent. So I am proving that this is equal. After proving that as equal,
1 equals 2.
yeah, but how to prove that? Now what is
First you have to like say that like EBA plus angle 1 equals 180, and then you do the same for angle
I prefer that. I prefer that to be explicit about it. Correct. So I
and then
prefer that.
and then for the last one you use
A
like the
plus angle 1 will be equal to 180. Linear pair. Again, I can say C ECB ECD plus angle 2 will be 180. Linear pair. After that, I can say, see, EBA is congruent to ECD, right? I can say 1 is congruent to 2. Why?
congruent supplements theorem.
See, if you're going to say that, then you don't have to say this at all. Meaning, if you're going to say the reason as congruent supplement theorem, the above two are not required. Congruent supplement.
Just say substitution, right?
Yeah. If you say substitution, then you need this.
Oh.
Okay. But if you say congruent supplement theorem, you don't need this at all. You see what I mean, huh?
Yeah. Well, but you can still leave it there and say the congruent supplements, right?
There is no. Why are you proving that they are linear pair?
So you don't need to?
You don't need to, in my opinion. You see what I mean, huh? Meaning you have proven that these. Yeah, you can leave it as it is as well because you're saying that they form linear pair, congruent supplement theorem. Yeah, you can leave it as it is. I agree, Manav. See, I'm always open to your thoughts as well. It makes sense, then I'll have to agree. This definitely makes sense. It's okay to have that linear pair. And then you can say the congruent supplements theorem. This was a difficult one. Meaning, actually, it never struck me that it was an isosceles triangle. Good job. Can I move on? Guys, unless we write more. Manya, are you with me?
Yeah.
You'll have to write more proofs. That is the only way to learn this. You want to do one more or log off and do it for yourself at home? What do you want to do? I'll go with you.
Can we do one more?
Sure. Okay, how about this? I can give you an easy one. You want to prove congruence or CPCTC you want to do? Which one do you want to do? I'm okay. You can choose. Okay, let me go ahead and give you the angle proof. This one. How about this? Okay, you can do this one. Can we try this one? Quick comma. Let's see. This one is an easy one. Then when they ask you to prove triangle congruence, it's very easy. C is the midpoint of AE and DB. Okay, given. Then what next?
1 equals 2.
AE and DB. Oh, okay. What am I? 1 equal to 2. No. Please. Let's go to that later. There's something.
AC equals EC.
That's better. AC.
Oh,
Because
I thought that's
there
what
has to be a direct connection from the above. AC is equal to,
EC.
EC.
yeah, C. Okay. EC. Okay.
And DC is equal to CB.
Yep.
No. Then you and then can you say angle 1 is angle 2?
Later. Let's finish the sequence. AC is, C is the midpoint of AE. You did. C is the midpoint of DB. What can you say? BC is congruent to CD, right? Definition of midpoint. Then
1 equals 2.
this is congruent to this. This is congruent to this. 1 is equal to 2. 1 is congruent to 2. Why?
Vertical angle theorem.
Vertical angle theorem.
And then
And then what?
C equals EDC. SAS.
Triangle ABC is congruent to triangle EDC SAS. Good job. Many of you, see, you're getting along slowly. But see, volunteer and answer in class. That's the only way to get proofs. Okay. So sometimes okay. Now if they ask you, let me change this. Okay. They ask you to prove AB is congruent to D. What can you do for that? Continue the proof. If this is to
Say
prove.
AB equals to DE now because
Yeah, now you can say AB is congruent to D. What is the reasoning?
CPCTC.
PPCTC. Very nice. Could you use AAS? AEB, EDC, AAS.
No, but they only give you one angle.
Mm.
So they only
Nisha.
give you one.
Go ahead, Manav. Go ahead.
Oh, nothing. I just said they only gave one angle, so you can't use AAS.
Does that make sense, Prisha? They've given only one angle, right? We are talking about only one. Prisha, are you there with me?
Yeah, no, that makes sense. I didn't ask
Oh,
anything though.
okay.
The one that I sent in the chat, that was for like the last to last.
Last one, did I not clarify that?
No, I got that. That was for like the last to last question that we did.
Okay, sorry. But
No.
if you want me to bring it back, I'll bring it back.
No, I get it.
Okay. Any other questions? Okay, I'll leave it here, but then I'll give you a bunch of theorems. Please write I'll give you a bunch of proofs. Please do the proofs at home. Okay, then go for any exam that you have. Okay. Next week we'll continue with triangles, similarity, triangles, special segments, concurrency, and then we'll move on to similarity. Any questions? Please work. Particularly if you're not taking geometry in school, definitely work on the homework. Okay, if you're not doing it, you're losing everything. There's no point in the class. Okay. Yeah, if you have questions, stay and ask. Otherwise, you can log off.
Bye.
Bye, ma. Bye, ma.
Miss Priya,
Yes, ma.
I had a quick question.
Yes, ma.
So basically, they started flow proofs in our school, and like their biggest thing, like even for like triangle proofs, they want us to do only flow proofs.
Uh.
So wait, could you like just, you don't even have to like get a word problem, but can you just show me like the quick format of how to do a flow proof?
Flow proof. Ma, flow proof. If you know this, right, there is nothing different in flow proof. Meaning, if
Yeah,
you know,
because I like this method better. I don't like flow proofs because there's too many arrows and everything.
I'll tell you, ma. Ma, whatever is hanging, right? This is okay. This is given, right?
Mm-hmm.
From this, what you can achieve. So statement, you're going to say C midpoint. Okay, I'm just writing it short. Okay,
Mm-hmm.
C midpoint. Okay, the reasoning is given. Correct.
Yeah.
From this, you can branch out these two. Meaning, this is the reason. This is the reason for us to tell these two. Correct.
Yeah.
So you say AC is equal to AC. I'm not doing it perfectly. Okay, congruent. Now you say
BC.
BC is C congruent to ED. Same meaning. If you are able to write this, BC is CD. Okay, the reasoning will be again definition of midpoint, whatever you write on the right side.
Mm-hmm.
Okay, definition of midpoint, right?
Yeah.
So the next one, when you look at it, there is no relation between the three. You get it?
Yeah.
So you write it separately. Measure of angle 1 is congruent to measure of angle 2. Meaning, you know what? I would really write down first 1 is congruent to 2. If I wanted to be very clear, I would write angle 1 is congruent to angle 2. What is that? Vertical angle theorem. And then I would say, measure of angle 1 is equal to measure of angle 1 is equal to measure of angle 2. Definition of congruence. You see, this is how I write, because this stems from this and this has nothing to stem from. You get it, huh?
Yeah, see, that's where I get confused. Because is it okay if I write it as like a completely different circuit, or I don't have to put it like?
Yeah, you don't, because there is no relation, right? You cannot put an arrow there.
Okay, yeah. That's, yeah. Okay.
Logically, when you think about it, right? Meaning, even if you write a two-way proof, right?
Mm-hmm.
This does not stem from any of these. It is separate. Now see. How can you say ABC is congruent to EDC? All the three come into picture. This
Okay.
S, what is this? A.
A.
So you can say the reasoning is SAS congruence. Now,
Okay.
if they ask you to prove this one, right? From this it will stem. You can say AB is congruent to DE. Outside you will say CPCTC. You get it, huh?
Yeah.
If you draw arrows from something, this should be your parent-children. Relationship should be there.
Okay.
If you don't have a parent, you say it separately.
Okay. Okay.
For this one bit, right, you have three parents. Then only it is SAS congruence, right?
Yeah.
Got it?
Yeah.
I'll stop here then.
All right. Thank you.
Got a gist, huh?
Yeah.
Okay.
Thank you.
Bye, ma'am.
Miss Priya, so I had a question. The problem that we just did.
Mhm.
Can you bring that back? Like the writing?
You're right.
Yeah, like the problem solving that we just did here, the statements and reasoning.
That I don't know. Yeah.
Yeah. So for this one, I like for like the part where it says triangle ABC is congruent to EDC.
Uh-huh.
Would it be SSA? I did not get why it'd be SAS.
There is no SSA and there is no AAA. Again and again and repeating this.
But how would it be SAS?
Okay. So this is congruent to this. This is congruent to this. This is congruent. The included angle between the sides is congruent. So what is that? Go on a clockwise or an anti-clockwise direction. SAS.
But aren't we starting from? It says EDC, so wouldn't we start from like where it says?
No. ED. They have given EDC. That does not matter. What is given, what is known to you. You know this side, this angle, this side. Only that you can use it to say congruent.
So you can't use AB or DE
You
because
cannot use AB or DE because that's not even given. Nothing, no detail is given about it.
Oh, okay, that
Got it?
makes sense. Yeah. Oh, and also, could you explain like the CPCTC? I did not get what that meant.
Once you say that this triangle is congruent to this, right? What do you say about AB and ED?
A, B, and ED.
Once you prove that the triangles are congruent, right? What can you say about AB and ED?
Could you say that A, B, and DE are congruent?
Correct. Why? Why? We have already proven that they are congruent triangles. So corresponding parts, these are the corresponding parts. This part is similar to this part of the triangle. Corresponding parts of congruent triangles are congruent.
Oh, okay, that makes more sense.
Got it?
Yes, I think.
Anything else?
And no, that's it. Thank you.
No problem. Bye-bye. Have a nice week ahead. Ma.
You too. Bye.
Bye.